We're about to go over 13. Let me just share my screen. Sorry. Okay, perfect. So more on linear function. The learning objective. So write the equation of a line parallel perpendicular to another and passing through a given point. Find the average rate of change between 2 points on a nonlinear function. So just more on what we talked about for 12, which was just linear functions in general. So two lines are parallel if they have the same slope. So slope 1 equals slope 2. The slope of the lines, the slopes of parallel lines, oh, sorry, here are equal. There we go. Are equal. My red pen might be dying. Let me try to grab a different one. But two lines are perpendicular if they have opposite reciprocals. Okay, or here, the slopes of perpendicular lines are opposite reciprocal. Oh, sorry, let me turn my phone on mute. There we go. Sorry if you heard that. Okay, so two lines are perpendicular if slope 1 times slope 2 is equal to -1. Okay, they're opposite reciprocals, meaning that opposite meaning sign change. Sign change. And reciprocal meaning like numerator denominator switch. Okay. So for example, if slope 1 is say, I don't know, 3, then perpendicular to 3 would be -1/3. So like this M with a little like upside down T that kind of makes this 90-degree angle, that is perpendicular slope. So here, for example, if M1 is equal to 7, then M2 is equal to 7. Those are parallel slopes, almost like M with two lines under it. Okay, like not 11, it's two lines, technically speaking. Okay, so they're just the same. Excuse me. So write the equation of a line parallel to y equaling -5x minus 3 that passes through the point 2, comma -12. Sorry, let me scooch. In point slope form and slope intercept form. So remember that point slope form is y minus y1 equals m times x minus x1. And sloped intercept is that y equals mx plus b. Okay, so if I want parallel, then this is in slope intercept form. That's the -5 is the slope for that equation there. So then parallel slope is also, so if I want it to pass through the point 2, -12, then we can use point slope form. Remember, it's called point slope because they called it like they thought. You use a slope and a point to create the line. Say that y will now plus 12 for the double negative equals 5 times x minus 2. And there you go. That is just what it is in point slope form. You wouldn't go any further. So if I want slope intercept form, now we solve for y. So if I go up and over, y plus 12 equals 5x minus 10. So if I subtract the 12 over, y equals 5x minus 22. Okay. So now I want you to pause the video and try example 2. When you're ready to please press play, but try to first for perpendicular. And here this is in standard form. Again, I would recommend that you put it in slope intercept form, y equals mx plus b. Grab the slope, take the opposite reciprocal. Here's the point, and then do what we did up here. So there's a little bit extra to it, I know, but you can do it. So pause the video and then press play when you're ready. Okay, so now we have to get this into, oh, excuse me. Sorry, I guess I'm tired. I can't stop yawning. So letters on one side, numbers on the other. Remember, this is standard form of a line, so we want to get this into uh slope-intercept form. So we want to solve for y. So I'm going to kick x over. So 3y equals negative x plus 13. So then divide by 3. So y equals negative 1/3 x plus 13 over 3. And remember, we're just trying to get perpendicular, so I don't really care about the plus 13/3 at this point. We're really just concerned with the 1/3. Okay, so if this is the slope, then perpendicular slope, right? So sign changes, so negative to positive, and then flip. So perpendicular to this line is 3. So this was like the added step for example 2 that example 1 did not have. Okay. So now that we have our perpendicular slope and a point, we can use a point slope form, or, let's start doing something different. Let's put it with using straight into straight, slope intercept. So y is the 2, so 2 goes in for y. 3 is the slope, x is 7, and now we're just solving for b. So 2 equals 21 plus b. So b is equal to negative 19. So y equals 3x minus 19. So if I want it in standard form, we just add the 3x over and then we're done. There's going to be subtract 3x, pardon me. And then, yeah, I think it's, yeah, well, if we technically put it equal to 0, although I don't think your book is that picky. That's standard form. Yay! So I did it a little differently just so that y'all could see different forms or techniques to go about it. Just remember, because I don't want to like handcuff you to one certain thing. Okay, so then average rate of change. Average rate of change is just super fancy for slope. Okay, well, not even that fancy. It's just rate of change, and then it's an average rate of change. So again, mathematicians, what do you know? Called it like they thought. Okay, it's fancier. Say fancier. Oops, fancier for slope. Okay, so let me read this to you, and then I'll explain. The average rate of change measures the change over an interval for any function, not just line. It is the slope of the line connecting 2 points, x1, f of x1, and x2, f of x2. So let me draw a pretty picture. Suppose here's a function, and maybe we look like this. Oops, but make it smooth and continuous. I just can't draw well, sorry. Ooh, okay. So maybe it just kind of looks like that. Well, if I wanted to know, say this is x1 and this is x2, if I want the average rate of change between these 2 points, we're literally just connecting the dots. We're creating this line, which is called a secant line. Secant line. And we just find the slope of this line. So sometimes called n sub sec for n sub secant, right? The slope of this line is equal to the average rate of change, AROC, average rate of change, my little shorthand notation. So if I find the slope of this line, it tells us our average rate of change. So basically, we just connect the dots of 2 intervals from here to here and find slope. So the whole f business is, so here's f of x of 1, but remember, that's just y. Here, if I could draw, that'd be awesome. F of x of 2, again, that also is just y. So if this is y1, that would be y2. So the only difference here is that you're going to generally have to go find your y. Your interval, like at this example, -3 to 3, this is your x of 1 to x of 2. So generally you'll be given the x's and you got to go find the y's. It's like you've graduated, now let's do fancier things. So slope of the secant line is still just change in y over change in x, right? Slope is not changing. Slope is slope. It's still rise over run. But now we just use function notation. That's really it. It's nothing too crazy, not a bunch of like fancy like hand waving going on here, just using function notation rather than y1, y2. That's it. Okay, so if I want to find the average rate of change for this from -3 to 3, well, here we don't have a picture. That's totally fine because I have the equation, which is sometimes even better. So f of x of 1 is f of -3, which is 3 times -3 cubed minus 1. This is also, let's see, -3 cubed is negative, what, 27? Times 3 is -81. Because also if you think about it, this is 4 threes or 9 squared, which is 81. This is -81 minus 1, which is -82. Let me grab my calculator, I'll show you. It's around here somewhere. Hang on. Ah, got it. So 3 times -3 cubed, -81, and then minus 1 more is -82. So then we need f of x of 2, which was just f of 3. So now this is 3 times 3 cubed minus 1. So this is really just 3 to the 4th. And then minus 1 is 80. So we just have slope. So slope of the secant line, which is our average rate of change, AROC, average rate of change, average rate of change. This is f of x of 2. Remember, this is just fancy for y sub 2. Oops, sorry, you can't see what I'm writing. Let me scooch. This is just y sub 2, f of x of 2, y sub 2. So this is 80 minus -82 or plus 82 over 3 plus 3, because the double negative. So 80 plus 82 is 162 divided by 6 is 27. And I just popped that into my calculator. So the average rate of change for this is 27. So let me show you. Let me throw it into my equation here. So this is 3x cubed minus 1. Let me do a zoom 6. So standard 10 by 10 window. Boop, boop, boop. So if I trace to -3, that's down there at -82. And then if oh here, let me change my window. That's fine. My negative, let's go -100 to 100, and we'll go tick marks of 10. There we go. Okay, so remember, these tick marks are tick marks of 10, which is why it looked like it got fatter, right? It was really skinny, but now it looks a little like smoosh, bloop, looks wider, just because remember I changed the window. These are tick marks of 1. These are tick marks of 10. Just keep that in mind. So if I trace to -82, oh, excuse me, trace to -3, so we're there. And then if I trace to 3, and that's there. Basically, we found the slope between my 2 points, my 2 fingers right here to here-ish. Let's see, if I could draw right there, okay, so ish, okay, pretend. The slope of that line would be 27. So that's essentially what we found. The slope of just that line, 27. There we go, all gone. All right, so 4. I want you to stop the video, try 4, and then when you're ready, press play. Okay. The graph illustrates the decay of a radioactive substance over T days. Estimate the average decay rate from T of 5 to T15. So here to here, for sake of argument, let's say that's 5 comma 12 and 15. I don't know. It's not quite 7, but I wouldn't say it's not quite 6 either. For sake of argument, we're just going to call it 15 comma 6 to make our lives easier. I hope y'all are okay with that. If you got a little more like 6.5 with it, that's fine. We're just estimating. We're just practicing. Okay, so that's just an estimation of the graph, a little bit of things to make our lives easier. But remember, this is just slope. Okay, this is just y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's it. We are just finding the average rate of change, or basically what is the slope between these 2 points. That's all we're doing. So the slope of this blue line. Okay, remember this is called a secant line. Yay, good one. Okay, so this is just 6 minus 12 over 15 minus 5. And because we're decreasing, we do expect this number to be negative. This is negative 6 over 10. So negative 6/10 or negative what? 2/5, which is also negative 0.4. Okay, so on average, a decreasing at a rate of negative 0.4. That's it. All right, and then that's even it all for just section 13. Okay, so up next is 14. I always forget how to stop the stupid recording. Please forgive my super long, annoying stop. Okay, here it is. Bye.